Hi, welcome. Hello, everyone. I am the current artist and curator of the Art of Science program at the Carl R. Woese Institute for Genomic Biology. And our interdisciplinary science institute not only supports incredible genomic research, we also work to communicate that research to the public. So we have a guest today. Thank you for coming. Will you please introduce yourself and tell us a little bit about the kind of science that you do?
My name is Elizabeth Rowland, and I just finished my PhD this summer studying archaeal virus host interactions. And I've just started a new position here at UIUC looking at HIV latency in tissues and imaging those guys. But this work was based on my PhD work, looking at the microbial systems and looking at virus host interaction in archaea.
Awesome. So you started to get into it, but what can you tell us about what is featured in this image?
Yeah, so this image is really kind of cool, and it was also really informative into sort of interpreting the research. So in the image is a cell, an archaeal cell, Cephalopus icelandicus. These guys are about 1 micron in diameter. They live in hot springs, and with extruding from that cell, you can see virus particles. So the virus that's extruding here is Cephalopus super elliptical virus. It's a brand new type of virus with unique morphology. I set out to characterize this new virus, and when we looked at this under the transmission electron microscope, this is a negative stained image, we could actually see the viruses coming off the host cell. And that helped us sort of interpret how these viruses are actually being released from an infected cell.
Cool. I've just read a little bit about some of the ideas around that, like there's theories around how viruses entering cells is a part of like how cells have become more complicated, like people looking at like mitochondrial cells entering or are like older cells that have entered cells, and that's how we've gotten more complicated cells. That was a poor description, but
Oh, but it's true. Evolution is fascinating, and how the nucleus formed, whether we're talking about mitochondria or viruses, there are a lot of theories of how that happened.
Cool. So can you tell us about how specifically imaging, like science imagery, influences your research?
Sure. So these archaeal viruses are fascinating in that they have like very unique morphology. So some of their morphology are shared with bacteria and eukaryotes, but some of them are completely their own between like bottle caps and claws and all sorts of unique things. So when we classify viruses, we sort of start from what they look like. And then we figure out what their nucleic acid contents are like and all the different lifestyles that they might have. So by being able to image them and look at how they change the cell and how they exist within the cell to create more of themselves, and then also be released into the environment, being able to look at them, imaging them, whether it be transmission electron microscopy in this case, or fluorescence microscopy, we can really sort of visualize and see what's happening. And that is integral in terms of understanding the biology of what's happening.
Cool. That's awesome. Yeah, when I was working with your images, I was using like a thermal pool colorations to like make the color gradient in the back of it to sort of like put it in its home location. And it was really interesting. So there's some video versions of the work too, and trying to find these like sort of soft movements, because I can imagine, like just the idea of these sort of the like permeations of it, that it's like it's not just about this like still image, it's about seeing these two entities kind of interact. So it's really cool for me to play around with that visually.
That is really cool. I mean, they come from hot springs, so you can see the steam coming off of the springs, because we're talking 80 degrees centigrade sometimes, So that's pretty hot, and you can have any sort of springs that sort of range from, the very calm to the bubbling springs that we sample from. So these guys come from a variety of different types of these sort of thermal locations.
Awesome. Thank you so much. I really appreciate you chatting today, and I'm so glad we get to put your images out there.
Thank you for your work, and appreciate being able to come and talk.
Bye.